Okay, so just to test things out, can anyone go ahead and use the chat? Does chat work? Can folks use the group chat? Okay, I'm not seeing anyone with able to use the group chat here. Let me try going over to show chat. Okay, does this chat work? Huh, okay. Okay, so odd. I need to figure out how does chatting work. Let me click on this. Oh, I might be streaming. Okay. Okay, so I see there's a chat window on the actual YouTube page. Let me try it. Can you see this? Okay, great. So we have a chat. I see Mark and Kieran can both chat with me on the YouTube page here. So if folks have questions, ask the questions through the YouTube page here that you're watching the stream through. I'm going to turn off, I'm going to ignore the chat within. Actually, if I'm going through slides, feel free to use the slide chat feature to kind of interrupt and ask your question there. The slide pack that I'm going to go through is here. Okay, so that's the slide pack on Google. So for about 10 minutes or so, I'll go through slides, and then I'll launch into the actual demo, which I'll get set up momentarily. And when I do the demo, I'll have a session open on the right-hand side here, so I'll switch over to it. So in just a moment, I'll start screen sharing. I'll give folks a few minutes to join us, and then start maybe 3 minutes past the hour once other folks are here. Okay, so in the meantime, get my tutorial ready. Okay, can everyone see my screen? Great, okay. We'll give folks one more minute and then I'll get started. And I'm assuming, okay, great, thanks Karen and Mark. Oh, thanks Dave too. And thank you, Hardeep. Great to see you guys on the call. I wish I could actually hear your voices. This is a one-way streaming service, so it's just over chat that I can communicate with you guys. Okay, so it's 3 minutes past the hour. Let's see if there's so it looks like we've got about 8 viewers listening to this, which is great. Thanks for joining us. I'll go ahead and get started here and do the presentation. In fact, what I'll do is I'll leave this in normal mode, so that way if there's chat, that I'll see it. So feel free to go ahead and use the Google Docs chat window here if you have questions while I'm going through the slides. Otherwise, we'll fall back to the chat window here next to the streaming video as I'm going through the sort of live demo. Okay, so today I'm going to give you a tutorial on how to register items in Dockstore, why you would want to do that, why it's useful for reproducible science. And I'm basically going to go over the documentation that we have on the live website. If any of you have attended one of these in the past, I had a wiki entry that I would use for a tutorial before, but I'm happy to say all of the documentation has been moved to dockstore.org. So if you end up following through on our documentation online, you should get the same sort of tutorial. This tutorial is also going to be streamed on YouTube, saved on YouTube, so you can watch it again later. And we have slightly older versions of this tutorial that are saved on YouTube as well, so you can watch those videos. They're largely the same content, so feel free to pick whichever one you like and use that as a reference in the future. Okay, so an overview of what we're going to talk about today. I'm going to tell you a little bit about Docker and why it's useful. I'm going to give you context about using it in PCOG, which I'm guessing many of you folks are very familiar with PCOG and working on that project. And then we're going to look a little bit as to the goals for using Dockstore with PCOG, specifically with regards to our upcoming publications that many folks are working hard on at the moment. I'm going to tell you a little bit about how this all ties in with Dockstore, and then we're going to actually walk through the process of creating and sharing a tool in Dockstore. And in the future, there'll be several more repeats of this particular tutorial. I'm actually going to be going to England soon, so Kieran, I hope to give a hands-on tutorial in person at Sanger in the not-too-distant future, and I'll hopefully live stream that as well. And we're also looking to adapt the PCOG infrastructure that the technical working group has built to do larger scale work. So I'm hoping that a future tutorial, probably after the new year, would be how we at the Santa Cruz Genomics Institute have used the PCOG infrastructure to actually run these tools at scale, which I think will be an interesting future tutorial. But this one today is really focused on what do we need to do as a community to get our tools and workflows in a state that's ready for publication around the PCOG project. So first of all, probably many of you folks are already familiar with Docker. For those of you that are new to it, Docker is a really nice technology that solves a lot of the algorithm mobility issues that have come up or are sort of omnipresent in the scientific computing community. And what it is it allows you to package workflow definitions, config files, reference files, and tools themselves into a lightweight and highly mobile container, or AKA image. These are Linux-based environments. These are supported on all major Linux distributions that are recent. It's incredibly popular in the IT community, where people use them a lot for deploying services. And there are fantastic tools out there like Quay.io and Docker Hub that integrate really well with the Docker infrastructure, and also tools that we're accustomed to already like Bitbucket and GitHub. So it's a wonderful way of essentially packaging up all your tools, your workflows, everything into a bundle that can easily be moved around and essentially be guaranteed to execute in any environment that executes Docker. And so this is a big change for us. A lot of the time in the past, you basically give someone a README, your source code, and hope that they compile it. So this really eliminates the need for that. So what did we do with PCOG in the tech working group with regards to Docker and Dockstore? So within the PCOG tech working group, we were tasked with taking the 2,800 cancer donors, which correspond to about 5,800 whole human genomes, and to apply sort of core analysis pipelines to those donors, so we would have consistently analyzed data. And this was variant calling and alignment pipelines, as well as consensus calling. So we had to do that in 14 cloud and HPC environments around the world, and our data was stored in 8 sites around the world. So you can kind of see how Docker actually would be a very good fit with this project, because we had to send the algorithm to so many different places and have it be guaranteed to work and produce the same results. We really needed a technology that would allow us to do that. The workflows, I'm sure most of you are familiar with these, but the core analysis workflows were BWA MEM-based alignment, and Sanger, DKFZ, and the Broad best practice pipelines for calling semantic variants, along with a filter and merge strategy. So these blue dots here represent these sort of quote-unquote core analysis workflows. And our intention here is to Dockerize all of these, which we did for the analysis, and to now publish these on Dockstore. So how did we use it within the PCOG project? There were many iterations of our infrastructure, including our first version of our infrastructure, which built miniature HPC clusters in cloud environments and installed software in a very traditional way, using bash shell scripts to literally compile and install software as we needed to do compute on those nodes. And you can imagine that was a very error-prone and dicey sort of operation to set up everything sort of from scratch on those nodes. So what we ended up with are, multiple rounds of architecture later, we ended up with a system that basically used a cloud orchestrator in each of the 14 cloud and sort of HPC environments that we worked in, would pull work that needed to be done based on a central metadata index, and then essentially turn on compute VMs, worker nodes, that would then dequeue work from the work queue, and it would run the pipelines as Docker images, Docker containers. And so the idea there is there was no need to install software from scratch. Everything was fully installed and configured within Docker, and the worker nodes, whether they're on a commercial cloud or an academic cloud, the worker nodes would then use those Docker-based workflows to run our analysis. And so you can see over time, that turned out to be a very effective architecture. It really helped to address a lot of the issues that we had with the project. And many, if not pretty much all of the work showing here is using that Docker-based approach. Okay, so how does Dockstore fit into this? Dockstore is a formalization of the process that I just described, basically taking what we learned about making mobile tools and workflows in Docker and formalizing that into a site that helps other scientists follow the same sort of best practices for Dockerizing their tools and sharing them with the community. So for the context of PCOG, we wanted to take the final workflows for PCOG, the core analysis, remove their PCOG specific code and put them on Dockstore so we could share them with the community, and other people could use those workflows to complement the large data set from PCOG with their own data. So we wanted final versions of those core pipelines. They should produce the same results as we did for the primary analysis. And likewise, and that's why I'm excited to see you guys on this call, is we want other working groups within PCOG to use the same approach so we can basically point to our full collection of tools and workflows that were used in PCOG, hosted on Dockstore, and encapsulated in Docker so other people can use them to reproduce the work, to complement the work with their own analysis of their own data. Hopefully, knock on wood, the timing is pretty tight here, but on the core analysis side, we're trying to get all of our pipelines onto Dockstore to coincide with the papers coming out, the coordinated papers coming out. And really, if we're doing this correctly, we should be able to have other systems use what's registered on Dockstore as well. So that's work that's ongoing with entities like DNA Stack and 7 Bridges to now support things that are registered on Dockstore and their platforms. And I'm particularly excited about that. So I've talked a lot about the reason of why we're doing, oops, so I'll put that over here. I've talked a lot about why we're putting things in Docker and why we're registering on Dockstore, but what does Dockstore really do? So the key innovation behind Dockstore is not packaging things up in Docker. That's been done before, and that's a really sort of standardized thing to do. What's the key innovation of Dockstore is we coupled those package tools in Docker with a standardized descriptor format that would tell you how to execute those tools inside that Docker. And that surprisingly is a missing piece in the community. If you go to Quay.io or Docker Hub and you find something cool that you want to run, you have to literally start reading the documentation to figure out where they install the tool, what are the parameters that that tool takes. It's a very human-specific process. It's a process that requires a human to read through a README. So we used CWL, Common Workflow Language, or Workflow Descriptor Language, WDL, to describe in a format that both machines and humans can read what is the tool inside that Docker image and how do you execute it. And so that's really the powerful thing about Dockstore. The other thing that's nice about Dockstore is we didn't try and reinvent the wheel. Dockstore is designed to integrate with the services that most of us use already and like, and that includes GitHub for storing our Dockerfile, the definition of how to make your Docker image, and the dockstore.cwl, the descriptor of how to call that tool. That's stored alongside with your source code at GitHub. And then we use Quay or Docker Hub to build that Docker image and host it. We also support Bitbucket, I should say, on the source side. And what Dockstore is really doing is it's bringing together the versions of your tool on Quay or Docker Hub, the Docker images there, and it's bringing together the releases of your software on GitHub or Bitbucket, and it's linking those two together and documenting them in such a way that makes it easy for us or other systems like Seven Bridges or DNA Stack to actually be able to execute those tools. The other thing I want to mention is we thought it was a good idea to try and establish a standard around how you do that, how you actually say, here's the tool in Docker Hub, here's the descriptor of how to run the tool. So we were working with the GA4GH to establish a GA4GH tool registry API. So this means in the future that other sites can host images, Docker images and descriptors like Dockstore, but be compatible with Dockstore. So in that way, we essentially are hoping that in the future, we have a nice federated model where there are many repositories like Dockstore, where you can share your Docker-based tools, your workflows, described with CWL or WDL, and have that all work with a variety of execution platforms. So that's really exciting, and we're looking forward to, on the Dockstore side, between Santa Cruz and OICR and other Dockstore contributors out there, we're looking to make that happen in early 2017 to actually have partnerships with other platforms that can execute, and partnerships with other platforms that want to redistribute Docker-based tools in the same way. Okay, so hopefully that is helpful background information on what Dockstore is, what it's trying to do, and how it relates to our PCOG efforts, in particular our goal of publication and linking to published tools through our papers. So I think that's really the bottom line for many of us on this call that are participants in PCOG. Okay, so now I'm going to switch gears and I'm actually going to walk you through a tutorial of how to create your first tool in Dockstore. So again, some of you may have seen this tutorial already. For those of you trying to follow along, I'm going off of all of the documentation on dockstore.org. So I'm basically going to walk you through that. So if you're having problems following it along in real time, that's okay. You can watch this video again later, or you can go ahead and walk through our documentation again later. It's all online, which is great. Okay, so here I am. I've gone on to Dockstore. I'm just going to start from the beginning. It's a little bit bumped up in size. Hopefully folks can see this. Now I'll periodically check back here and see if there's any comments for me or questions for me in the chat within the YouTube video. Okay. So back here, I'll just give you a very brief tour of Dockstore. So this is the site that you see when you first go to dockstore.org. We have the most recent tools listed here. We have the ability to browse tools and also workflows written in CWL and WDL. Here I'm going to search for PCOG. So you can see we have a live search. And these are all the PCOG related tools that myself and Kieran and other people have put together. I'll just go ahead and take a look at the Sanger pipeline. And what you can see here is this is really bringing together your source code on GitHub, your Docker image on Quay.io, and documentation. The nice thing is every tool in Dockstore is executed in the same way. So that's probably from an end user perspective, that's probably the nicest feature. Not only do we have this history of versioning, but we also have this standardized way of executing a tool. So this means that every time you pull a new tool from Dockstore and want to use it, you don't have to relearn the way that you execute a particular tool. It's always using the same sort of strategy of you create a JSON file with the parameters in it, and then you can execute it with this command. Speaking of versioning here, what we're doing is we're establishing clear versioning between your source code in GitHub and what was then built on Quay.io or Docker Hub. And so you can see for this particular tool, we have multiple versions. We can always go back to older versions of this tool. We can see details about this. And if I look at the Dockerfile, I can look at previous versions of the Dockerfile. This shows the most recent one. These are the instructions on how you create your tool. And then this is the descriptor that describes how to actually execute that tool. Again, here are your inputs, your outputs, the base command that you use to construct the command that you run. So I'm briefly going over this, but I'm going to dive into the details of how I do this now. Okay, so what you want to do when you're getting started with Dockstore is I do my development on an Ubuntu 14 or Ubuntu 16 box. Other environments will work. One tip, if you're working on Mac OS, the Docker native version it's not currently compatible with our process and a lot of other processes as well. So I would avoid the Docker native version for Mac OS and go with the Docker tools version that uses VirtualBox underneath the hood. I'd recommend that you use that approach if you're going to build and test your tools on Mac OS. But for the vast majority of us, we're probably working on an Ubuntu box. I'm going to go ahead and just get started with this. The first thing that you want to do when you start working with Dockstore is go ahead and establish accounts. I won't show you how to do that, but we have links here. We recommend that you use GitHub, and we recommend that you use Quay.io for building and storing and sharing your Docker images. You can use Docker Hub. You can use Bitbucket as well. The only reason we recommend against using Docker Hub is that they don't have an API, and that means it's more manual work to register items in Dockstore, whereas since Quay.io does provide Dockstore an API, we can do a lot of the heavy lifting for you, and the registration, which you'll see in a bit, is pretty much a push button to activate something that you've built on Quay.io to present it through Dockstore. Okay, so the other thing that you want to do is you want to check your Java version. So you need to have Java installed. These directions tell you all the details about what needs to be installed. But do a quick check to make sure your Java version's okay, your Docker version's okay, CWL tools is installed properly, and the Dockstore command line is installed properly. Now, you may have questions about how you do all of this. When you first sign up for an account, it will walk you through this wizard that gives you all the instructions you need to install all the dependencies I just talked about. So all of the information about getting your Dockstore command line, your Docker, your CWL tools, all that information is included here as you go through what we call the onboarding wizard. Okay, so at that point, your environment is set up. I've already checked my environment here, that everything is good to go. Before I move on, let me just check and see if there's any questions over here. Okay, good. So it doesn't look like we have any questions. I'll go back here. So at this point, what we're going to do is I'm going to create a new tool. And in this case, my demo, it's going to be something called BAMStats, which I'm sure some of you guys have used. It basically is a simple tool that will take a BAM file and generate an HTML report giving you statistics about that BAM file. So in order to make a Docker image that has that tool in it, I'm going to go ahead and create a Dockerfile and walk you through the Docker creation process. Now, for those of you that are interested, if I click on this and go over here, we have a repository that has all of this already set up in it. And what I'd recommend is you guys go ahead and fork this repository. It's the same demo, it's the same process that I've done on my side. I forked this repository and used it to walk through the tutorial that I'm giving you today. So I'd recommend that you do that rather than doing everything by hand. We'll walk through the contents of the Docker file now. So you can see this Docker file. I have my own copy over here. So this Docker file has the recipe for how to create an Ubuntu-based box that has BAMStats properly installed in it. And so we'll walk through a little bit of the details. If you notice that there's anything out of sync with this tutorial text and what you forked and grabbed from our BAMStats sample repository, go with what's in the BAMStats GitHub repository. That's kept up to date. And sometimes the documentation may lag a little bit behind. But generally speaking, all the information I'm showing you today is pretty translatable to exactly what's over here. So you can see in the first line, what I'm doing here is I'm saying, I'm going to base my Docker image on Ubuntu and specifically 14.04. We'd highly recommend that you use something basic, something from a trusted source like Ubuntu, versus using someone else's Docker image that you found on Quay or Docker Hub. For security reasons, the other thing that I'd recommend, specific version of Ubuntu. Otherwise, you may get a nasty surprise in the future as they upgrade releases. If you just say from Ubuntu, you're constantly pulling in the new release. The other thing that's helpful here is providing a maintainer, someone that can be contacted if someone else is trying to extend your Docker file or has questions about your Docker file or your Docker image that's built with it. The next part is a series of commands that first of all switches to the root user, because we're going to do some things to create this image that require root privileges. And the next thing it's going to do is install a bunch of software using, for Ubuntu, the standardized way that you install software. And so this is using aptget. So you can see here, we're doing a bunch of aptget, update, and install together. And that's another recommendation. If you're doing software install, that you do it in a single step, aka a single sort of line here in the Docker file. The next thing I'm doing is I'm pulling BAMStats 1.25 from a public repository that hosts it. And then the next step here is I'm basically unzipping that and moving that to my install directory, opt. Okay, so just to underscore, this is why Docker is so awesome. If you're working in an HPC environment, this whole process would require you to go talk to someone, talk to an admin, ask them to do this, ask them if doing this will impact any other users on the system. You typically would go through that process, and it might take anywhere from a few hours to literally days or weeks to get permission to install this in an HPC environment. So this is really why Docker is so powerful. You as a developer can set up your environment, set up your Docker image in whatever way you like. You have full control, you have root access, you can do whatever you want in that image to get your software set up and working properly. And so that's, again, why Docker is so powerful. The next thing that we're going to do in the Docker file is I'm going to copy in a script that I wrote and is present. If I quit out here and do an ls, there's a script here in bin called BAMStats, and I'll just go ahead and cat this, bin BAMStats. And this is just a very simple script that acts as my sort of wrapper around BAMStats that'll handle parameterization coming in and call BAMStats properly. And so you can see all that it's doing here is really setting up and calling a Java command, and it takes 2 parameters, the amount of memory in gigabytes, and then the input BAM file. Then it creates a zip file that contains all the reports. So a very, very simple script. So in this line, I'm basically moving that script, I'm copying it into my Docker image and change modding it so anyone can execute it. And then finally, at the very end of my Dockerfile, I've created an Ubuntu user, and I've switched to that Ubuntu user by default. And what this does is it sets up your Docker image so that when you execute it and turn it into a running Docker container, the commands that get executed will be owned by Ubuntu. And this is another recommendation for Docker files. It's recommended that you use a non-privileged user when running your code and your tools inside of a Docker container, because if you have root, it sometimes makes it more difficult to integrate that into other people's infrastructures. What'll happen is your output files that are coming out of your Docker container will then be owned by root. So you have to be cautious about that. And then finally, there's a command bin bash. So that's basically saying by default, this Docker container, when it runs, will execute bin bash and give me a shell environment that I can work in. That really won't be used later on when we start using CWL. Okay, so there's a ton that can be said about Docker files and how to make a Docker file and make a Docker image. It's a ton of documentation on docs.docker.com. It really is a general IT solution out there. So you'll have a ton of people that will write good guides, that have written good guides for providing information on how to build Docker files and Docker images. So I encourage you to check those out, including this best practices for writing Docker files, which is a really helpful document. Okay, but at this point in the demo, I have my Docker file. I have my ability to now create my Docker image. So what I'm going to do is I have to be a little bit careful here, because I'm going to build a Docker image and I'm going to give it a name that's meaningful later on in our process. So really quickly, I'm just going to go back to my own repository. This is my fork of that repository where I'm doing my own work. And I can see back here, I've released, the last release that I made was 1.25-8. That was my last release that I've made of my version of the Dockstore tool BAMStats. So that's really helpful here, because what I want to do when I'm building and testing my Docker image locally is I want to now move to 1.25-9 because I'm working on the next version of this tool. So I'm just going to go ahead and go back here, and I should have it in my history. Docker builds. Yeah, so Docker build -t for the tag, and I'm going to name it Quay.io, Brian D. O'Connor, Dockstore tool BAMStats 1.25-, and now I will change that to 9. And this dot here is saying build it in the current directory. There should be a Docker file in the current working directory. The other thing that I want to point out is you could actually name this whatever you want here, but I'm naming it what will it will eventually be called when I have Quay.io build this tool for me. So I know that it's always going to start with Quay.io. I know that my organization in GitHub is my own personal, Brian D. O'Connor, and then I'm going to call this tool Dockstore tool BAMStats. And this is the this is the next version of the release tag. So let's go ahead and just build that. Okay, so we're looking for this. We're looking for successfully built. Whew, glad that worked. Okay, so now we're going to move on to the next task. I'm just going to do a quick, you can actually look within your Docker daemon and ask it, oh, which BAMStats do I have? And you can see here, here's what I did last night. Here's what I did just now. It says 14 hours ago because there's no difference in these two, right? So it's reusing. That's why the build happened suspiciously quickly. But we now have both of the tags, 2.5-8 and 2.5 1.2.5, 1.25-9. Right, I will eventually get that correct. Okay, so now that I've built the thing, I need to test it. I need to actually make sure this thing runs. So we'll go ahead, Docker run. Let's walk through what this command is doing. Docker here, run, IT, that gives me an interactive session. I'm going to mount the current working directory as home Ubuntu. So this -v is an important and useful parameter. So this current directory that I'm in will appear as home Ubuntu, home/Ubuntu, inside my running Docker container. And this is the mechanism by which you can harvest files coming out of a Docker container. Then I'm going to use the tag that I was using before. And the only thing that's different is I need to go back here. I'm now using 9. And finally, I'm going to execute bin bash, which will give me a shell. So the next thing I'm going to do is I'm going to go into home Ubuntu. Now you notice that all these files here are the same as the output, as the outside directory that we're just in. And the next thing I'm going to do is I better get some sample data here. So let me go ahead and download some sample data so we have some sample BAM file that we can use. Okay, so this will just take a couple minutes to download. And at this point, I'm going to copy this. We're going to try and execute BAMstats from within your running Docker container. Okay, great. So that's done. We do an ls. We can now see the BAM file is there. I'm going to run. Again, I'm running inside my Docker container. The BAMstats convenience tool was installed in user local bin BAMstats. I'm going to give it 4 gigs of RAM, and I'm going to give it the path to the file that I just downloaded. Okay, so that's going to run. While it runs, we already talked about the contents of this helper script, and we've already talked about the -v parameterization being your mechanism to mount in directories. Okay, so stuff has happened. Now if I do an ls, I should see I have a BAMstats report.zip, and you can see it's greater than 0, so there's stuff inside of it. If I exit and transferred that to my local laptop here and unzipped it, what I would get is an HTML report that looks very similar to this. And you basically would be able to browse the statistics about this particular BAM file. Okay, so at this point, you could stop here. You've successfully made your Dockerfile. It has allowed you to successfully build a Docker image that has your tool of interest inside of it. You've shown that you can launch that Docker image as a running Docker container, go inside of it, run a tool, have a -v mount point that you write the output of that tool to, and you can exit here. Exit. I will now actually see that there's a BAMstats report. So that mounted directory has allowed me to retrieve some analysis that I did inside my running Docker container. So you could, in theory, stop here. We could just end the tutorial and I could go get a coffee, but that's not going to happen. We're going to push on. But in theory, you could stop here because you have a working Docker image. We're going to look at the next steps, though, of how to take that working Docker image, document how to run the tool inside of it in a human and machine readable way, and get it registered on Dockstore to try and optimize and try and maximize the reusability of your tool with the community, and also develop something that you can then point back to in your publications. So with that, I'm going to go back here. I'm going to see any questions. This would be a good stopping point if anyone has any questions. Okay, I'll check back in just a second while I load this page. Okay, so it sounds like we don't have any questions right now. We've got 11 viewers, so good. Folks aren't dropping off. Thank you for sticking around. Okay, so we're gonna work on the second half of the talk now, which is how do you take this Docker image to the next level, right? How do you increase your ability to have it run by different types of systems, have it be more visible to the community, make it easier on folks to understand how to run your tool inside of it. Because if I gave you the BAMStats Docker image right now and said, yeah, there's BAMStats inside of it, sort of standardized way of figuring out that BAMStats is installed in user local bin BAMStats. You'd have to go searching in the container, you'd have to ask me. So let's talk about a better way of describing the tools and potentially other components that are inside your Docker image. And for this, we're going to use something called Common Workflow Language. You can use WDL, which is the Broad's alternative or complementary technology to CWL. Very, very similar. CWL tends to be a little bit more expressive. WDL tends to be a little bit more streamlined. But they're both great technologies for describing tools and workflows. We're going to use CWL here to provide that human and machine readable description of your tool. And getting into it, there are recommendations for the minimal fields that we really recommend everyone has in their dockstore.cwl file. This allows us to present the minimal information that we need on Dockstore without having things being sort of empty fields or not available on the Dockstore. Okay, so we provide an example in our repository. I'm going to take a look at mine. Again, what I would say is if there are any slight discrepancies between the documentation here and what you find on our BAMStats sample, go with what you find in the BAMStats sample. We keep that up to date. I'm going to walk you through the individual sections, though, just like I did for the Dockerfile. So the first thing is the section that describes some very basic background information and version information. So you can see the first thing is saying that this CWL file defines a tool. A tool takes inputs, has outputs, and has a base command that those inputs and other parameterization are used with to actually run the tool. This is not a workflow. There are, as the name would suggest, common workflow language. You can describe whole workflows of many different tools strung together in CWL. But for the purposes of Dockstore and the work that we're doing here, we're describing a single tool with CWL. I should say Dockstore does support registration of CWL or WDL-based workflows as well, but those are just individual documents that are registered on Dockstore versus a document plus a Docker image, which we're doing here. Okay, so in this case, the description is actually used by the Dockstore site to provide a description. It supports Markdown, so you can nicely format your description field here. The other thing that's quite useful is this section that is referring to the authorship of this tool. So you can see over here, this is, I'm forgetting what the name of, Dublin Core, I think is the name of the schema. And it's allowing me to put in information about who is the creator. There's also a contributor too. What I tend to do here is I tend to put my name because I'm the creator of the CWL. Other people may feel it's most appropriate to put the author of the original tool here and put yourself as a contributor rather than a creator. That's perfectly valid as well. The reason I tend to put myself as creator here, even if I'm wrapping someone else's tool, is I think the creator is really referring to the CWL, and I want someone to be able to contact me if they have questions about running my CWL. So that's why I'm putting my own name here. But I'll leave it up to you whether you decide to use your own name or if you put the original author for the tool. Perhaps they're the same, so that doesn't really matter. The next thing is this requirement section. This is where we actually specify the Docker used. So we just built our Docker image, and in my case, I'm calling it, from my forked version, I'm calling it Quay.io, Brian D. O'Connor, Dockstore tool BAMStats 1.25-8 was the previous version. So now I'm going to go over here and I'm going to change that to 9. That's the version we just built. Okay, the next section, this really isn't supported by us in the Dockstore command line, which you'll see execution a little bit later. But other systems may use this information to appropriately schedule out your work to a node that has sufficient resources. So I do recommend, if at all possible, if you know this information ahead of time, documenting what sort of resources your tool is going to require. And then in the next section, we're down to the inputs. So this tool, as you saw in the command line, it takes two parameters. One is the amount of memory in gigabytes, so it's an int here. And the other one is the BAM file that you want to perform your statistics on. So in this case, it's a type file. It's the second position. This is the first position. A little bit description. And the format, and this is really helpful and interesting. The format supports ontology terms. In this case, I'm providing a URL to the EDM ontology, which has descriptions of many different common bioinformatics file types. And so this will become more important in the future as systems start using CWL to string together multiple tools and understand what's the format of the input, what's the format of the output, so we can effectively allow for in the future sort of interfaces that know when tools can and can't be connected together. So it's a great thing for you to do to actually specify the format of your inputs and outputs. The next section is looking at the outputs. In this section, I'm saying that my output is a file. It's a zip file, which is this EDM term. And then it's matching BAMStats report.zip. So that's saying that wherever my tool is being executed, in that directory, it's producing a BAMStats report.zip. And this syntax here allows CWL to understand where it's going to find your output file. Finally, base command, I'm using bash and executing that script that I wrote, the BAMStats script that I wrote. That is used with the inputs to construct a command. Okay, so hopefully you can see that we can describe in a both machine and human readable way what are the inputs, what are the outputs, and how do you construct your command to actually execute that tool. So you'll also notice that everything we're doing, I'm working locally on my Ubuntu VM over here. I haven't pushed anything to Quay.io or anything like that. You can do your full life cycle of development locally, and then when you're happy with it, do your release on GitHub, do your build on Quay.io. I'll walk you through that in just a few minutes. Okay, so at this point, I'm going to need to go ahead and set up a test of my CWL and make sure that I can run my Docker tool as I did manually before. I can run that, my Docker-based tool, I can run that through CWL this time instead of just manually launching the Docker image and manually running it. So let's go ahead and get some sample data. I already happen to have this file available, so I'm not going to download it again, but I am going to move it to a place that I'm going to refer to in my configuration for running this. So I'm going to actually, okay, so I've moved my BAM file to the /temp directory. And this is just because I happen to have sample configurations for running my CWL described Docker-based tool, where I pointed to that file in temp. This is the input. This is the output, which I've specified should also be written to /temp so I can find it later. Okay, so when you write CWL, you can have this JSON format for your parameters. That's essentially what this is. It's a parameterization file. Okay, so I now have that completed. One tip here is your input paths can be HTTP URLs, S3 URLs, SFTP URLs. The Dockstore tool that I'm going to show you how to run this with supports multiple locations of where to provision your data from. Likewise, output can be a local file path like it is here, or it can be an S3 URL. Okay, so at this point, I'm going to actually run the tool. Again, instead of running it directly through Docker, I'm going to run it through Dockstore, which interprets the CWL, looks at your parameterization, and runs your tool. So I'm going to do this. Again, in this directory, I have my Dockstore CWL. I have my sample configuration. And now I'm going to go ahead. Oops. Okay, so this is going to take a little while. Hopefully nothing will fail. As a tip, I'm just going to tell you a tip. As this is running, it does tell you underneath the hood what it's actually calling. In this case, it's calling CWL tools because your descriptor is CWL based, and it's calling this whole command. So if there was a problem with running your tool, you could actually run this directly and get more additional debug information. That's an incredibly handy thing to point out to you guys, because as you start getting into development and registration of tools on Dockstore, you'll want to go ahead and be able to do debugging. You're not going to get this perfect the first time out the gate. So take a look at the CWL tool that it's command that it's running directly and use that for your debugging purposes. When you run this, it'll also tell you the Docker run that it's doing. So you'll see more debug information when you run this directly. And you can look at the direct Docker run and see what sort of debugging information you can glean from that as well. So that's very, very helpful. Let's see though if this finished running. Yes, so it ran the tool. You can see here, here's the Docker run behind the scenes, right? So you can get an idea of exactly what it's doing. You can see that I'm running 1.25-9, and then you can see the output from that tool. So it's running appropriately. It's creating my zip file of reports, and now it's provisioning my file back out to, in this case, I specified the temp directory. So let me take a look at that. Yeah, and in fact, we can see, yes, great. So this was a tool that ran inside of a running Docker container, did my data processing, and provisioned my output file back out to my host system. So this is exactly what we want to see. Okay, so let me see if there's any questions or comments. Okay, so I'm not seeing any questions or comments so far in the chat window here. So I'll continue on. So what's happening behind the scenes, and what the Dockstore command line is doing, we want to give you a simple tool, a simple command line that would allow you to execute these tools that are registered in Dockstore. And so what the Dockstore command line is doing when you do this tool launch, when you do the Dockstore tool launch, is first of all, it looks at your JSON file, provisions downloads from the internet or S3 or other locations, provisions all your input files, prepares the pull to the Docker images, calls CWL tools if you've described this with CWL, calls Cromwell if you've described this with WDL, and provides all the paths to the files that it downloaded. This executes your tool in a running Docker container, and then CWL tool or Cromwell is going to harvest the output, and the Dockstore command line is going to take that harvested output, those harvested output files, and then provision them to where you want them to go. In our case, that was just to the temp directory, but you could imagine that could be back to S3, or that could be back to another sort of protocol like SFTP. Okay, so hopefully you can see that this is a very simple, consistent way. And the other point I want to make is the way that you run Dockstore-based tools is always like this. It always follows the same pattern. So it makes it very easy to understand, to learn how to use a tool and how to execute that tool. Okay, so the next thing we're going to do is, my tool worked beautifully fine, no issues at all, nothing crashed. So the next thing I'm going to do is now I'm going to start sharing this with the world. So I'm going to do multiple steps. First, I'm going to release it on GitHub, freeze my source code, make sure everything is released on GitHub. Then I'm going to have Quay.io build and host that Docker image so anyone else can pull that Docker image and use it. And then I'll be able to register on Dockstore so I can advertise and show people how to use my tool. So the first thing we're going to do is we're going to do release on GitHub. You can see the last release was 1.25. What I need to do here is, let me check out my status. So I've got one modified file. This now has the updated release tag in it. So I'm just going to do git commit a message release git push. Oops, git push. Okay, great. So now I've pushed all my changes back up to develop, and I can go onto GitHub and I can say draft a new release. 1.25-9. It's coming from develop. I'll just do 1.25-9 and publish release. Great, super, super easy. We now have 1.25-9 released on GitHub. So all of my source code for this tool is safely released and under a release tag that anyone can reference in the future. The other thing I would recommend here is using Zenodo to generate DOIs for each of your releases. So that's something I would recommend. We'll probably be adding that to the tutorial here. That's a great way to have, especially for publications, to have a DOI that journals recognize and can interact with. Okay, so now that I've had all my source code released, I want to build my Docker image not on my local machine, but I want to have Quay.io build it for me, so I don't have to worry about hosting this for the world. So I'm going to go Quay.io, and I probably have probably am logged in already. But if not, go ahead and sign in, create a new account. This is just like GitHub or Bitbucket, where it's free to use as long as it's an open repository. If you want to have private repositories, then they charge a small fee per month. So let me go ahead and sign in. Okay, so now all of my repositories that I own or am associated with are on the left-hand side here. I'm going to click on this guy, and here's my own personal series of repositories. You can see I already have a Dockstore tool, BAMStats. Normally, if you don't have your tool in here already, you would create a new repository, and you'd name it like Dockstore tool BAMStats. I'm not going to do that because obviously this already exists, but I'm just going to kind of walk you through, and then I won't do the final click here. So I'm going to make this public, and you could either link to a Bitbucket or a GitHub repository because those are the two sites that we support for Dockstore. In the future, we'd like to look at other repository backends as well, especially GitLab has been requested. So normally now you would create this, but I'm not going to create it because I already have this repository created. So I'm going to go back to my repositories. I'm going to click on that. I'm going to click on the Dockstore tool BAMStats repository. And I'm going to show you the tags that I currently have. So you can see I have latest develop. I have 1.25 all the way up to 1.25-8. So we need to make a 1.25-9 that corresponds to our software release. So let me go ahead and do that. Under builds, I'm going to create a new trigger to a GitHub repository push. So we just did a release. Now it's going to ask me which repository do I want to do. Okay, so I'm going to click here. I'm going to start typing Brian D. O'Connor. Dockstore tool BAMStats auto completes for me, which is nice. Okay, I'm going to match a particular release branch, in this case 1.25-9. My Dockerfile is in the root directory, so that's fine. And then I'm going to create a trigger. And I'm going to run the trigger right now to say, please build 1.25-9. I've checked it in, I've released it on GitHub. I would like you to pull that into Quay and build it on Quay. So I'm going to click run. And I'm going to go for the one we just created, and I'm going to start that build. And so depending on how busy Quay.io is, it can take anywhere from a few minutes to For a more complicated Docker, could take 20, 30 minutes to actually build this thing. There are limits, so you want to be a little bit careful that if your tool is super complicated and does a lot of compilation, you want to be careful about that, because you can run into a situation where Quay.io will eventually time out if your container doesn't build in, say, an hour or less. So be a little careful about that. We tend to use released artifacts of compiled code rather than building everything from scratch on a Docker image. Okay, so that's going to build in the background. I'm going to go back to the tutorial. So all of this information is shown here. It's a little bit tricky, I realize, but it's documented well here. There is the alternative of doing a WDL descriptor, but we won't cover that today. In this stage, it's actually talking about linking your accounts. So I'm assuming you did that through our onboarding process. And now the final step is we've tested everything locally. We've written a CWL descriptor to go with our Docker image. Everything checks out. I'm now having Docker, my Docker image built on Quay.io, the source released on GitHub. The next thing is now I need to take the link to the source, the link to the Docker image on Quay, and I need to bring them together on Dockstore and present them to the world. So that's really what's happening here. Because I used Quay and I used GitHub or Bitbucket, and I used our sort of recommended process, I can take advantage of registering my tool on Dockstore with a single click. So let me show you how to do that. Okay, so I've already logged in to Dockstore. By the way, the login is based on GitHub, so that's another reason we recommend GitHub. You click on My Tools. Now you're going to see all the different Quay repositories that I've built under my own account or accounts that I'm associated with. And you can see here are the tools under my own personal account. I've already registered BAMStats. And you can see here a preview of what an end user is going to see. You actually see a live container building logo indicating that the container is actively building right now. And if you click over here, you see all the previous versions, including 1.25-8, which is the version I did last night when I checked out the tutorial. What we're going to do here is, hopefully, I'm going to refresh this page. Hopefully this finishes its build quickly. It may take a little while. So if this had finished right now, what I would do is I would go over here, I would click the refresh button, and it would have pick up that new 1.25-9 image. Unfortunately, that's still building right now, but if it did pick it up, it would have appeared here, and you could do things like enabling it or disabling it. When you're done and happy with your tool, you can click this button up here to toggle. If it's published, it's listed on Dockstore. If it's unpublished, and if I click this right now, it would unpublish it from Dockstore. So really, if you followed this SOP, if you followed this development process that I showed you today, you can do all your development locally, all your testing locally, and then when you're happy with it, you can get your GitHub release done, you can get your image built on Quay.io, and if you use those two services, you can publish or unpublish your tool directly through the Dockstore UI. The other thing I should say is this whole process actually can be done on the command line as well. So you can script this whole process. You don't have to actually do it through the GUI. I like to use the GUI because I follow the standard operating procedure. If you don't follow the standard operating procedure, let's say you have to use Docker Hub, there is a provision here for manually registering based on your Docker Hub URLs. So you can manually register items from Quay or Docker Hub. That is a possibility that you can do in order to utilize things on Docker Hub. Again, we like Quay, so we recommend that one because it does integrate quite well with our tool set. So at this point, once I've registered, it really is very easy then to share this with other people. So if I want someone to use my tool, I can go ahead and send them the link that appears on Dockstore. I can reference that in my papers, and that gives everyone a very standardized way to go ahead and use the tool, find out how to use the tool, find out what versions of the tool are available, and you can basically use that URL in your publications. So at this point, I'm just going to go back. I've shown you how to register and how to use tools on Dockstore. What is next? So at this point, if you have questions, please ask in our Gitter channel. CWL questions, they have their own Gitter channel. We can answer Dockstore questions. If you find bugs in Dockstore, please register them on our GitHub. You can ping me over email, but really Gitter is the better way to go because there are multiple people watching Gitter for Dockstore. And in the future, I'm planning on doing a repeat of this tutorial at least once more in the coming weeks. I'll post I'll post information about that into our Twitter account. On request, I can be available for Dockstore office hours. If you want some one-on-one help, just email me directly or ask on the Gitter channel. And in the future, after the new year, I'm hoping to do an advanced tutorial of how you use Dockstore as part of a larger system for executing Docker-based tools at scale. So with that, I just want to acknowledge Dockstore was founded and is being funded by the Cancer Genome Collaboratory at the Ontario Institute for Cancer Research, and is being developed in collaboration with the Global Alliance for Genomics and Health and my group here at UCSC at the Genomics Institute. And I just want to thank the Dockstore developers, in particular Dennis Ewan, who's the lead developer on Dockstore, and the PCOG technical working group, as well as the GA4GH containers and workflows task team, which is really trying to drive Dockstore and the API behind it as a standard. So with that, I'm going to go back, see if there are questions. Okay, I do see some questions. Great. Oh, and I see Dennis. Thank you, Dennis. I see Dennis has answered the question. Where should we send follow-up questions? Blah, blah. Yeah, okay, so I'm going to go ahead and, like I just said, there, it's in the slide pack here. I'm going to go ahead and post, I think probably the most important one. I'm going to cross-post that over here. Again, Getter is our first line of defense because multiple eyes are on that. So ask questions to Getter, create issues. If you do run into problems, we do ask you to create an issue on GitHub. So let me put that in the chat as well. Okay, and let us know if you want some one-on-one help. We're here to help. We really want PCOG tools that are referenced throughout the whole compendium of papers coming out. We would really love to see those tools registered in Dockstore because we believe it's a great platform for sharing. So if you need some one-on-one help, please reach out to the Gitter channel and we'll work with you to get your tools in Dockstore. And with that, I just want to thank you guys for showing up today and look forward to seeing your questions and having more folks try out Dockstore and the standards behind it. So thanks very much, everyone. I'll stay on for a bit more and see if there are more questions that come up on the chat channel here. I'll give you folks a few more minutes. Thanks very much, David. Thanks, Karen. Thanks for coming. Thanks, Mark. Thanks, Hardeep. Okay, I think that's probably it for questions. Again, hit us up on Gitter. I'm going to go ahead and stop the live stream now. And if you're interested, that slide pack that I showed today, it does have a link to the YouTube video as well. So there is a YouTube video that you can watch. It's basically the same one as today. This one will go live probably in the next couple hours. Okay, Kieran, that sounds great. Yeah, feel free to email me and cross-post to the Gitter if you can. That would be great. Looking forward to it. Great. Okay, thanks very much, everyone. I'm going to go ahead and stop the broadcast now. Thanks for your time.